Welcome students, we got an interesting question. Let me draw the circle. They are both lying on this plank and there is a square so A, B, C, D is a square. Now we are expected to find the area of the square. So we are also given the radius of these circles. So radius is given to be as 5 units or 5 feet, and both these circles are identical. So both C1 and C2 are identically equal, and we are expected to find the area. So let me change this: area of the square. This is needed. So excuse me. So what I'm going to do is I'm going to take the side of the square. Let the side of the square be equal to x units. So this is going to be x, and what I wish to do is all of the sides are x units, right? So let me drop perpendicular. So I'm going to be dropping a perpendicular from the center to the base. So this is going to be 5 units. This entire length is going to be 5 units. Fine. Now I will also connect. Let me take this as O. Now we will connect O with D. So I will connect O with D, and that is going to be 5 units. And then what I will do is I will take a point P and I will connect D with P. A lot of connections. Okay, I'll take this point as P. Connect P with D. Let PD be equal to Y units. Okay, so this is Y units, and this line which is drawn from O, let this point be Q. Okay, also OQ is equal to 5 units. So if AD is equal to X units, this means PQ is equal to X units. This in turn means OP, this entire thing is X, OP is actually equal to OQ minus PQ. OQ is 5 units, PQ is X, so OP is 5 minus X. OP is 5 minus X. Now this is 90. So consider, I'm going to use this side, consider triangle OPD, and since angle at P is 90, by Pythagoras theorem we get OP squared plus PD squared is equal to OD squared. OD squared is 5 squared, PD squared is Y squared, and OP squared is 5 negative X whole squared. And I'm going to represent this for Y. So Y squared is 25 negative 5 negative X whole squared. This is my Y. Now what I wish to do is I would like to extend C to this point. So this is O, and let me take this as some S. So from S I am dropping a perpendicular to R, and from C I am dropping a perpendicular to T. So PD is Y, so CT will be equal to Y. This distance is X. Okay, so now what I wish to do is I would also like to extend this region. Let me make this extension. From the point of connectivity I'm extending. So I have given two circles, C1 and C2, both are identical. So this is going to be 5 units. So what have you got? We have got Y plus X plus Y is equal to 5 plus 5, isn't it? So let me write that. Consider the rectangle. Consider the rectangle POST, right? POST, it's beautifully formed. And clearly, what do we get? Clearly, Y plus X plus Y, Y plus X plus Y, this entire length is equal to this plus this, right? 5 plus 5. So you got 2 times Y plus X is equal to 10. So 2Y is equal to 10 negative X. So Y is equal to 10 negative X divided by 2. Now you square this both sides. So if you square both sides, let me write that down. Squaring both sides, we get, so what do we get? You get Y squared is equal to 10 negative X whole squared divided by 4. But this is 1, this is 2. So equating 1 and 2, what do we get? Equating 1 and 2, we get 10 negative X whole squared divided by 4 is equal to 25 negative 5 negative X whole squared. Now let me move to the next page. So I would expand this and solve for X. So this is going to be 100 negative 20 times X positive X squared, and I'm going to move this 4 to this side. So it's going to be 4 times 25 negative 25, expand this, 10 times X, and you have a negative sign, so this will become positive because of the presence of a negative sign, and you have negative X squared. So you expand this 25 negative 25, this goes off, right? And then you have 40 times X negative 4 times X squared is equal to this entire quantity. So what I will do is I will bring everything to this side. So this is going to be X squared plus 4X squared negative 40X negative 20X positive 100 is equal to 0. You can add these two together and you get 5X squared negative 60X plus 100 is equal to 0. You divide by 5, you get X squared negative 12 times X positive 20 is equal to 0. So you need to get 12 and you need to get 20. So do you think we can factorize? If I were to factorize this, I would have to use excuse me, so you got 20 there, you got negative 12, so 10, negative 10, negative 2, negative 10 added with negative 2 will give me negative 12, negative 10 multiplied with negative 2 will give me 20. So this is going to be x negative 10 times x negative 2 is equal to 0. Yes, x into x squared, negative 10x, negative 2x and positive 20. So this is the factor. So this implies x negative 10 is equal to 0 or x negative 2 is equal to 0, x is equal to 2 and x is equal to 10. Now we cannot have both the solutions. Now x cannot be equal to 10. Why? Because the radii itself is 5 units. So if x is equal to 10, how is it going to be accommodated inside? Right? That's not going to be possible. So x is equal to 10 means this will stretch out. So this has to be dropped. So x is equal to 2 is the length of the side. So length of the side is x is equal to 2. So area is required. So therefore area of the square is x squared is 2 into 2 is equal to 4 square units. That is the area. Now in this question we are asked to find the area of this region. So how are we going to get the area of this region? So that's exactly what I'm going to do. So consider rectangle. What is that? I'm going to consider P, T, R, Q. P, T, R and Q. So what is the area of this rectangle? So this entire rectangle, this side is x units, so I know the value of x, right? And I have to get the length. Okay, the width is known. Width is x units is equal to 2 units. This is known. The length is, what is the length? Y plus x plus y. Length is y plus x plus y, which is equal to this entire length. Also we know that y plus x plus y is equal to, this entire length is 5 plus 5 and x is 2 units, so 2 times y plus 2 is equal to 10. So therefore 2y is equal to 10 minus 2, so 2y is equal to 8, so y is equal to 8 over 2, which is equal to 4. So y is equal to 4 units. The area of the rectangle is PT, we're talking about the rectangle PTRQ. RQ is length multiplied with width. Now y value, we have got y value to be as 4 units, right? So this is 4 units, 4 plus x value 2 plus another y. So 4 plus 4, 8 plus 2, 10 multiplied with width is 2 units. The width over here, x units, x is equal to 2. So that's going to be, area is 20 units, 20 square units. Okay, so from this region we have to take away this region. If we take away the area of the square, we need to take away this region also. So we take away the area of the square, we take away this 2 regions, and that would subsequently give us the area of the shaded region. So how are we going to do that? So for that, what I'm going to do is I need to get the area of the sector. So this is step 1. So what is the step? Step number 1, get the area of the sector. So what sector are we talking about? We are talking about O, sector OQD. So this entire thing. So for that, what I need to know is I need to know this theta. I need to know that theta, right? So this is actually 90 degrees. So if I were to take sine theta is equal to y, opposite side is y over hypotenuse side, which is 5 units. Y is obtained as 4 units. Let me show that value of y. Y is 4 units. So we will utilize that value of y. So 4 divided by 5. So theta is equal to sine inverse of 4 over 5. 4 over 5 is nothing but 0.8. So let me take the calculator and obtain sine inverse of 0.8. 0.8. What is that? That is, theta is approximately 53 degrees. So I'm going to utilize this 53 degrees. So area of the sector, is theta divided by 360 multiplied with pi r squared. Theta is 53 degrees divided by 360. Pi is retained. Radius is 5 squared. So this is 25. So 5, if I were to reduce this, I can either reduce this with the 5. So I take 1 5. This is going to give me 7 5s are 35, 1 72, right? So this is 53 divided by 72 multiplied with pi into 5. So this is the area of the sector. Now if you want, you can actually multiply 5 3s are 15, 1 25, 26. So 265 divided by 72 square units. This is the area of the sector. Now this is entire area. From this area I want to take away the area of the triangle. Now if I take away the area of the triangle, I would get this region, right? PQD. So let me write that down. Area of PQD is equal to area of sector. From the area of the sector, you take away the area of the triangle. What is the area you are trying to take away? OPD. So first let me find out the area of triangle OPD is equal to half times base into height. So half times, what is the base? Base is y units, right? The base is, okay, I would take the base as 5 negative x, not y. So this will be the height, right? It doesn't matter, whatever you want to take, you take. So the base is 5 negative x, the height is y units, x is 2 units, right? So this is 5 negative 2, that's 3 over 2 times y is 4, 2 divides here 2 times, so 6 square units. So area of PQD, right? Let me show you that. PQD, area of PQD is area of the sector 265 pi divided by 72 minus 6 units. So this is equal to 265 pi minus 6 2s are 12, 1, 6 7s are 42, 43 divided by 72. Now you can take the value of pi as 3.14 and find out this, what exactly is this, right? So I'm going to take the value of pi. So let me just take 22 divided by 7. Okay, and okay, let's take this value, the same value that you read there, multiplied by 265. So what do you get? You get 832, and from this you take away 432. So what do you get? You get 400.856 you divide by 72. So I'm going to take 400.86 you divide by 72. So this is the region 5.57 square units. Now why did I do all that? Because I'm interested in getting this. So from the area, from this entire area, I need to subtract the square's area that is gone, and then I need to subtract this area. So that would mean 2 times of this region I need to subtract. So we have to now, having got that, we have to now obtain the area. Let me use this part of the space, area of this region. We want this particular region. So the required, let me write that down, required area is nothing but from the area of the rectangle you take away first area of the square, right? And then there are 2 portions you need to take away this. So from this entire rectangle you take away the square, but still this region is there, but you need to take away this and this. So minus 2 times of, that is going to be area of this region, PQD. So PQD. Now rectangle area is 20, area of the square is 4 units, minus 2 times area of PQD is 5.57. So this is 20 minus 4, you multiply this, you get 11.14. So this 20 minus, you add these 2 things, you get 15.14. So from 20 you subtract 15.14. Anyway, you can perform that by hand. So 10, 6, 9, you take away 1, you get 8, and already you have a 9 there, you get a 4 there. So this is what you have got. So 4.86 square units. So what is this exactly? This is nothing but this region and this region together. Now probably they might ask you, what is this region? So in that case you need to divide it by 2 and say the area of this region is this. So this is a beautiful question, and we have achieved this. So please like, share and subscribe to our channel until we meet again. Thank you.